Okay, um, I'm recording this lecture for you guys because I'm going to be away this week, but we're just going to discuss more about reconstitution and measures of central tendency. So we'll just get started. So the learning objectives for this week, we'll just read them out quickly here. We want to further explore the process of reconstitution and define the terms of solvent, diluent, solute, and solution so that we can use them interchangeably to describe our reconstituted medications so that we have a firm understanding of what we're creating, what we're mixing with what to create, our final solution or medication. We also want to be able to interpret directions on the drug labels for reconstitution of medications supplied in powder form so that we're adequately creating dosages that kind of match what we're trying to administer to our patients. And we'll talk about that as we go through the lecture. We also want to do a few calculations of reconstituted medications so that we can see kind of how those calculations happen, what we need to do in order to calculate dosages based on reconstituted medications. And then we're going to talk about the concept of spreadsheets in collecting statistical data. So in nursing, we do a lot of nursing research, and we need to know how to interpret some of this information, not only for our own benefit, for the benefit of our patients as well, if they have questions, doing appropriate health teaching, things like that. So we're just going to touch on what these look like, kind of the important statistical analyses that we need to understand for the concept of this course. And then we're going to investigate the fundamental tools used in data analysis. So that is the mean, the median, and the mode, which you will likely already be a little bit familiar with from your elementary school education or even high school educations. It's something that they discuss a lot in mathematics. So we're just going to look at these three measures of central tendency, and then we're going to kind of look at a spreadsheet and see how they're calculated. And then we want to be able to apply these different calculations, that of mean, median, and mode, in research data to give us more information about the research data we're looking at. Okay. So let's talk a little bit more about reconstitution. So some medications, as we talked about in the previous slide in the learning objectives, are supplied in the form of a powder. And what these look like, it's essentially a small vial, and there's powder in the bottom. The label will have the drug name and also a chart describing different concentrations of the medication that you can create by adding different amounts of diluent, or, most of the time it's water that we're adding as the universal solvent, which you would have discussed in the chemistry course you needed before doing the RPN. So this is called reconstitution. So when we add a liquid to a powdered form of a medication before it can be administered to create a specific concentration of that medication so that we can then administer it to that patient. So when you add a solvent or diluent to a solute being the powder, solvent, diluent being the substance you use to, dissolve that powder, the amount of drug always remains the same, but the overall volume, depending on how much solvent or diluent that you are adding, will increase. So that basically means, think about a jar of, like a concentrated orange juice, for example. Okay, if we have our orange juice concentrate and we put it in our jug, well, maybe I'm the type of person who likes my orange juice basically pulp and barely any water. So I can choose to add just 1 can of water to that orange juice and then drink it. Well, then on the other side of the coin, maybe I'm someone who likes my orange juice very watery, basically just flavored water. So I could take that can of concentrate and I could add 5 cans of water, and it could make it very diluted. Well, it's the same kind of idea that we're talking about with the reconstituted medication. And of course, at the bottom there, you can see, think of hot chocolate. Same thing with hot chocolate powder as with the orange juice. We're taking that concentrate and we're diluting it either very little to make it very concentrated, right? So very strong tasting, or we are adding a lot of diluent and we are making it very watery tasting, right? It's the same idea as reconstituted medication. We're either making it very concentrated or we're making it more diluted by adding more solvent or diluent to that solute. And again, solvent amount never changing. That's the amount of the drug, okay? So let's talk again about reconstitution terms. So we'll talk in terms of the hot chocolate powder, okay? So the solute, a substance to be dissolved or diluted. It can come again in solid or in liquid form. So in this example, we're using our hot chocolate powder. So we see our packet of powder there. So that's our solute. That is what is to be dissolved. And in this case, it's in a solid powder form. Okay. Now, our solvent or diluent, as discussed on the previous slide, is a liquid substance that then dissolves another substance. So in this case, we're using hot water, or perhaps you make your hot chocolate with hot steaming milk. Same thing. That milk would be our solvent or diluent because it is taking our solute or our hot chocolate powder and is dissolving it into solution. Okay, so the resulting solution, as we see at the bottom there, just circle that. So our resulting solution, okay, is that mixing of the solute and the solvent, resulting in our nice warm cup of cocoa or hot chocolate. Okay, so we mix the water with the hot chocolate. The amount of chocolate powder does not change, right? In this case, we're using a packet. It's preordained how much powder is going to be in our packet, right? So that chocolate remains the same. Overall volume in the cup increases when we add our water. If I were to add more water than the recommendation on the package, it would dilute that hot chocolate further. If I were to add less water to that packet, it would then make it more concentrated, right? It wouldn't be that ideal consistency, or perhaps you prefer it more concentrated or more diluted. Okay? So, reconstitution of injectable medications found in powder form, as we've discussed. So when reconstituting these types of medications, you need to know how much and what type of solvent or diluent is to be used. So this information is always found on the drug label or the package insert. So pharmaceutical companies have been making these for a very long time. They give you all the information you are going to need right on that label or package insert to appropriately administer the medication. If for some reason you are looking at something in practice and you do not find all the information you require for it, you need to call pharmacy, or you can consult with a colleague and ensure that you're looking in the appropriate places. Perhaps you just missed it, those sorts of things. Because again, we're that last line of defense before administration. You don't want to just go with your best guess as to what that solvent should be, and if you can't find those concentration tables too. So those instructions also tell us the final concentration and, very importantly, the length of time. I'm sorry, I just scribbled all over that. The length of time that that medication is stable for once it has been reconstituted. Okay. Now, that stability is very important to us because if we're, for example, we have a patient who's on ANSEF and we've reconstituted it in a vial, well, perhaps this specific type is only good for 12 hours. It's only stable for 12 hours once reconstituted. What that means is that medication is only effective as drawn from that vial for that length of time. So if we were to administer it, our doctors ordered us 1 gram let's say Q 12 hours, okay? So that vial, even if it has 2 grams of medication in it and we've reconstituted it as 1 gram per mil or something like that, which we'll discuss later on and it won't sound so confusing. But if that medication, we draw up our first gram and we administer it, by the time we need our next dose, 12 hours will have elapsed. And as I said before, if that medication is only good as manufacturer recommendation for 12 hours, well, it's now garbage. So that stability has been lost. That medication will not be therapeutic for that person. It could even be, not only non-therapeutic, but it could even cause a problem. And we don't want to do that. So we always, always are looking at recommendations from the manufacturer. So not only are we looking at those concentrations, which are vitally important for dosage appropriateness, but we're also looking at the length of time it is stable once it's been reconstituted. Okay? So, as discussed, the most common solvent or diluent that we use in practice may be sterile water or normal saline. Now, on our packets that we're going to see, they use a different type of preservative-infused liquid. We'll talk about that, but for the most part, in practice, sterile water, normal saline. Okay? So always, with any medication you administer, but especially with reconstituted medications, check the expiry date, not only on your solvent or diluent, but also on your solute, because everything has an expiration date. And again, if it goes beyond that expiration date, then you're at risk for having, decreased therapeutic response to it. It could, be dangerous in some cases. So always checking those expiry dates. The label also provides different instructions sometimes for the reconstitution based on the route of administration. So, for example, if they're talking about an IM injection, okay, smaller volumes are typically utilized for intramuscular injection because a muscle is quite thick, the tissue perfusion is not great, so they can't take a lot of fluid. You know what I mean? There's not a lot of space between those muscle fibers, so they're very tightly packed. So only a small amount of volume can be injected into the muscle. Otherwise, it will just leak out, which I'm sure in your practice at some point you'll see and you'll think, oh, good grief, that's not good. Now, intravenous medication, on the other hand, okay, it's just going into your vein. There's lots of fluid in there. The same as us drinking more fluid and adding more to that, to that vascular space. So it can take more fluid. There's more, the particles are further apart, we'll say. Okay, it's easier, the compliance is better in the arteries than it is in the muscle. The muscle just doesn't accept things. So that's also something to keep in mind when critically thinking about on that label, that it's saying for different routes, different concentrations should be calculated to make it a smaller volume or a larger volume for administration purposes. Okay, so we'll move on. Okay, so here, excuse me, we're going to look, this is right from the textbook, okay, page 222 and 223, okay, so the course text, this is just a drug label, okay, and then reconstitution instructions on how to reconstitute a medication, okay. So, when we look at our cefazolin for injection, okay, it's a 500 milligram vial, okay, and you can see the indicated use here is for IM or IV administration only, okay. So, we're not injecting it subcutaneously, we're not injecting it intradermally, okay, only by manufacturer recommendation. It's IM or IV and that's it, okay. Now, you can see here there's a spot for the lot and the expiry date, okay, but because this is just a sample, it's not written there, okay, but it would be if you were in practice. So, it's kind of difficult to read, it's a little distorted, but what it says here, single dose vial only, which means you discard your unused portion, you do not save it for, subsequent administrations. If this person was having, over a course of period, a whole course of antibiotics, right? This is a one-time shot and then it's garbage, okay? So, as per the instructions, cefazolin, 500 milligrams and 24 milligrams of sodium. So, hence, cefazolin sodium, okay? Reconstitution, so if we were administering it IM, okay, you can see right here. If we were administering it IM, we're adding 2 milliliters of SWFI, and that's that's the basically the solvent that has the preservative in it, which we don't have access to most of the time, but anyways, then as we read further, the final concentration that will produce, okay, is 225 milligrams per milliliter, okay? So we know if we add 2 milliliters of solvent to our solute of 500 milligrams, our final concentration is going to be 225 milligrams per 1 milliliter. So if I asked you a medication dosage question based on this, what you need is this concentration, right? Because we're going back to that dock over stock times vehicle, and this is our stock. Okay, 225 milligrams per mil. Now, if I asked you instead for calculation as IV, okay, so let's look at that. IV, okay, C package insert. So in this case, I wouldn't ask you because it doesn't give you the concentrations or the dilution instructions. But then we read further, stable for 24 hours and at 25 degrees Celsius, okay, or 72 hours at 2 to 8 degrees Celsius, okay? So basically what that means is I could technically mix this up, okay, and keep it at room temperature, roughly, for 24 hours, or in the fridge for 72 hours, as long as that fridge is between 2 and 8 degrees Celsius. Now, for the most part, we're going to mix medication and we're going to give it. We don't pre-mix, but this manufacturer does state that you could. And again, it's a single dose vial, okay, meaning that we can only administer 1 dose from it, and then the rest is garbage, okay? So discard unused portion as stated. Okay, now, it also on this label gives us a usual adult dosage. So 250 milligrams to 1 gram every Q6 to 12. So if we were looking at our physician's order, we can always compare it to this usual dosage range to ensure that it's a therapeutic dose for this person. Okay? So that's that. So let's look at our reconstitution. Okay? So here in step 1, okay, we've calculated our dose, okay, for this medication. So once we know how much fluid we're going to need, okay, this is showing us injecting the same amount of air into the vial, okay? And the purpose of that is that these vials are sealed by the stopper at the top, which means if you try and draw fluid out of it, you're going to make a giant vacuum, and you're going to make it very difficult for yourself to pull that fluid out of that vial. So we add the air, right, so that we can take the fluid, and overall this doesn't create a vacuum in which we can't suck the fluid out because the pressure is too great. Okay, that's the purpose of the air. Now, once we have added our air, okay, we're going to draw back the amount, so in this case 2 milliliters, just as discussed on this label, okay, so that 2 mils. So we're going to draw back that amount of sterile water, okay. We are then, this is our reconstitution vial, this one right here, this one with the lovely green stuff in the bottom, okay. So this is our solute, our powder, okay, of cefazolin. So we're going to take our 2 milliliters of sterile water and we are going to inject it into our vial, okay, into our cefazolin vial, okay. We're going to make this beautiful, solution over here, okay. And then we're going to withdraw 1 milliliter because that's just what our dose happens to be in this case. Okay. That's not stipulated, but that's what they're showing here. So after we've reconstituted, we've given this a little shake, ensured that it's fully dissolved. We don't see any powder on the sides of the container. Okay, we're going to draw back our 1 ml. And the reason we don't have to inject air this time is because we're injecting fluid of 2 mils. So we're already adding that extra pressure so that we won't be creating a vacuum when we withdraw. Okay. And of course, between each one of these steps, we're cleaning the tops of these vials. Okay, but that's our reconstitution. Okay, water, we add air to our sterile water, we draw up our sterile water, we add that to our solute. We then mix it well, and then we can take back our dose based on manufacturer recommendation as to what this concentration will be. Okay. So let's talk single strength and single dose solutions. So there are two types of reconstituted solution, single strength and multiple strength. Okay. So single strength, they only have one recommended dilution direction and the resulting supply dosage printed on the label. So we can only make it in one form. Okay. There's only one amount of fluid you can add to that in order to make it the appropriate concentration, and that's it. More confusingly, we also have, we'll continue to talk with single strength. Okay, so most single strength vials will have that direction printed on their label, just like we saw in our cefazolin example on the previous slide. They usually do not have a preservative in them, which means that, as we discussed, you must discard it immediately after drawing up the medication because there's nothing to keep it from becoming unstable and no longer usable, right? Because those preservatives kind of keep everything stable, keep everything happy. That's how we can save them for a few days and that sort of thing at the appropriate temperature. But these single strength, single dose solutions typically don't do that because they predicate on the idea that you're going to use them right away, that it's only a single dose and you're going to draw it up and it's done. Okay? So let's continue. So an example of a single strength, single dose medication, this teeny tiny little label in the top corner. Okay? So azithromycin dihydrate, 400 milligrams IV daily times 2 days. So our supply, as per that teeny tiny label that we really can't see very well, okay, this guy. Ooh, made it huge. Anyways, this label up in the corner, okay? So, supply directions on a 500 milligram vial read, reconstitute to 100 milligrams per mil, okay, with 4.8 milliliters of sterile water, okay? So, what does that mean? That means we are going to add a solvent of sterile water as directed, right? And we're going to use how much of it? 4.8 milliliters, okay? So we're going to go back to our image on the previous slide. We're going to inject 4.8 milliliters of there into a bottle of sterile water, drop 4.8 milliliters of sterile water, okay? Step one. Let's go to step two. What is the resulting concentration of injecting that 4.8 milliliters of sterile water into our vial of 500 milligrams of azithromycin dihydrate? Okay. Well, it tells us, right? So it's going to be 100 milligrams per mil. It's going to be our final solution, right? So what is the total volume then of this reconstituted solution? Well, it tells us on the label, which is very tiny and hard to read, I apologize. But our total volume is going to be 5 mils. And that is because, okay, that water we added was only 4.8. So you think, where did the other 0.2 mils come from if our total volume is going to be 5? That is the volume of the powder that was already in the vial before you added the water. And for the most part, this won't come up on a test. I'm fairly certain I ensured that last time. But if it does, you just need to think that that powder takes up space. Okay, it's not just air. You know, it's a solid, so it takes up a volume. Well, it only takes up this much of the volume, right? 0.2 mils. So that's why our total is a little bit bigger than just the amount of fluid we added. Okay, so then it's going to ask us here in step 4, how many doses will we get from this vial? So if our order is for 400 milligrams, okay, and you can do this one of two ways. It's ordered for 400. Well, we know our vial only had 500 in it, right? So we can just logic out and say, well, obviously there's only enough for one dose. But we can also calculate how many mils would be a dose of 400 milligrams. And if it's 100 milligrams per mil, well, we can all kind of do that in our heads, but 400 divided by 100 times 1 mil is going to be 4 mils. Okay, so now we know our dose was only 4 mils. We know our total volume was only 5 mils. Sorry, that was a horrible way of doing that. Our total dose was only 5, okay? Which means we can only get 1 dose, so a single dose. So single dose vial, single dose. So we take out our single dose and we throw away the vial. Okay. So now let's discuss multiple strength, multi-dose solution. Okay. So this means that, just as the name indicates, we get multiple doses per vial. Okay. So typically, in contrast to the single dose vials, they have a preservative in them. And this preservative basically prevents bacteria from growing within the vial to contaminate the medication, right? We don't want to inject someone with bacteria that's sick. I mean, just think about that. So the preservative does not actually prevent infection if we don't appropriately administer the injectable medication. For example, our skin is covered in bacteria, okay? Now, there's contraindicated research that says, that cleaning with an alcohol swab doesn't really reduce the risk of infection, blah, blah, blah. But I'll leave it up to your best practice and judgment to look at the research and decide for yourself. But we typically clean the skin with an alcohol swab to prevent bacteria from being introduced to the dermis. Sorry, to the intradermal space. Okay? Now, so essentially what the statement is saying is that if you don't propagate this appropriate infection prevention protocol, then there is no guarantee that there will be no bacteria introduced. But what this is saying is that because the preservative is in the medication to begin with, they are not taking responsibility for growing bacteria in that person. So if there's a bacterial infection, it comes down on us. Okay. The same with intravenous administration. Always clean the ports before medication is being administered, and monitor the sites to ensure that there is no infection or infiltration and those kinds of fun things that you'll learn about as you go through. So, if you are using a multi-dose vial, okay, it's only for your patient. Okay, we do not get to share vials between patients. Okay, and the solution must be used within the recommended time frame and then discarded. Or if you don't use all the medication, automatically discard it. Okay, we don't want anyone else using vials between 2 patients. And that's just good practice anyways, because if you didn't mix it, you shouldn't be giving it. Unless it becomes pre-mixed from pharmacy or from the manufacturer, if you didn't mix it, you don't give it, because you cannot guarantee that the actual appropriate direction was followed. And it's not that we don't trust other colleagues or people, but it's best practice to ensure that you control your own behavior, you control your own decisions. And if you mixed it, you would know it was mixed appropriately. Okay, don't put yourself in those kinds of situations. It's just not fun. So, again, use in the recommended time frame or discard. And note that the date of expiry is different than the discard date. Okay, so that date of expiry is, that thing could sit on a shelf for however long in powder form and be fine, as opposed to once we've added that dilutant, there is a time frame that it is good for before it is no longer viable. Okay, so that time frame should always be stipulated on the vial, okay, if you're going to store it for multi-dose. So what do we label our vial with? We want the date and time of the preparation, strength that we've prepared, right? The length of potency, so how long is it good for, and storable directions, which should already be on the label, but we want to make sure it's there if it's on the package insert instead, and then we sign to say this is ours, don't touch. Okay? Multi-dose vials will very often have directions for preparing different strengths of a solution. And we'll see what that looks like in the next slide. Okay? So because they have different diluting directions, okay, as we discussed with the hot chocolate, the less dilutant you add, the more concentrated. Okay? The larger the amount of dilutant you add, the more dissolved, the more diluted it will be. Okay? So again, the hot chocolate. So let's look at a multi-strength, multi-dose solution. So this vial contains two different reconstitution instructions. Okay, one yields 500,000 international units per mil, and the other 2,500 or 250,000, sorry. Which, if we just do a quick little fun check, this is half of this, right? So this is more concentrated, right? We have more international units per mil. This is less concentrated, less international units per mil. Okay. So our medication is Pen G. So sorry, it's a penicillin. So we call it Pen G for short. But penicillin G, okay? And it's for, again, IM or IV use. Okay? So when we look at this drug label, here is this lovely little chart that gives us our different diluting instructions. Okay? And here we have, and it's a little difficult to read, but this is volume of dilutant. Okay? So that's our amount of sterile water. Okay? And then it says concentration, okay, in the middle there. And then it says volume. Okay, so that's final volume. So in the first one, we can see if we add 1.8 milliliters of dilutant, okay, we're going to get a concentration of 500,000 international units, okay, per 500,000 international units in 1 mil, okay, and our total volume at the end will be 2 mils, okay, and then at the bottom here, we have adding 3.8 mils, okay, gives us a total volume of 4 at the end, and our concentration is 250,000 international units per mil. Okay? Let's do an example. So our label says, and that's our label in the previous slide, to add 1.8 mils of diluent to get a final concentration of 500 international units per mil. So how much and what type of diluent? Well, on that label it also said sterile water, okay, was the diluent of choice. And then we know we're adding 1.8 because it's right in our chart. Okay, so that's that answer. What is the supply dosage? Okay, so in this case, we have two choices of what that will be, but if we're adding the 1.8, this is what this is talking about. So we add the 1.8. Our supply dosage is now 500. Good grief. Sorry about that. Our supply dosage is now 500,000 international units per mil. So, what is the resulting volume of the reconstituted solution? So we are adding our 1.8, okay, and it tells us our final volume is 2 mils, okay. So then we know, well, where did that 0.2 extra mil come from? That's the volume of our powder, okay, as we discussed. Now, example 1 continued. How many doses, then, are we able to get from this vial? So, in this case, our order is for 300,000 international units IM 4 times a day. Okay, so let's focus on the dosing. Okay, this is how much we need. So, convert. In this case, it's not necessary, right? Because our units are equivalent. So we have an order for 300,000 international units, and our calculated dose was 500,000 international units. So we don't have to convert units at this time. Okay, as stipulated here, that is right here. Okay, so now you could just do our little check, right? So we know we'll want to give a little more than half a mil. And this is our estimating answers bit again, as we did before. And that's because we know that we have 500,000 international units per mil, right? Our dose is 300,000 that we're looking for. So we know it's 250,000 would be half a mil, okay? So we know it's a little more than that, okay? But it's definitely not a full mil, right? Because that's smaller than that. So that just gives us that second check. So let's calculate. Okay, so here we go. We'll just use our fun little formula. So doc is ordering 300,000, okay, over our house stock, which is 500,000, okay, and then times our quantity or our vehicle, okay, 1 milliliter. So that's giving us, as discussed, and again, I apologize for covering that zero, that's giving us a little bit more than 0.5 of a mil, just like here in our estimation, right, our quick estimation of 0.6 mil, 0.6 milliliters. Okay, so that's one dose. Now, since this is a multi-dose vial, and we have a total of 2 milliliters at our disposal, we then take our 2 milliliters total volume. Apologize for this writing, it's terrible. So our 2 milliliters, and we're going to divide it by our 0.6, okay, milliliters per dose. And that's going to give us how many doses. So it actually ends up being just over 3, or yeah, just over 3. 3 point something. So that basically means that because it's over 3, okay, we can't use parts of a dose. We want to know how many total, like full doses. Okay, so that means that we can only say, okay, we can make 3. Sorry for the terrible scribbling, but you get the gist. Okay, so 2 milliliters divided by 0.6 milliliters gives us how many doses are available in that vial. Happens to be 3 point whatever. Okay, and so we know we can only take full doses into account because we can't use partial doses, right? So we know in total we can get 3 full doses. Okay, 3 full doses from the vial. Okay. So let's talk about a separate example. Example 2. So the label says to add 3.8 mils of diluent to get a final concentration of 250,000 international units per mil. Okay. So again, more diluent, weaker solution. So we're adding much more diluent this time. Okay, extra 2 mils. So how much and of what type of diluent are we going to use? 3.8, 0 water. Okay. What is our supplied dosaging? So when we add 3.8 mils, as per that little chart, we're going to get 250,000 international units per mil. Resulting volume of reconstituted solution is again on that little chart. So 3.8 mils of diluent, our volume of powder does not change, right? Because it's always the same. That amount of cocoa powder in the packet, preordained, we have no control over that. It's always the same. Gives us a total of 4 mils of solution. Okay, so it's all on the label. Again, how many full doses, sorry for the scribbling, full doses are we going to get from the vial? So our order is for, again, 300,000. Okay, so again, we start with conversion, which we don't need to do because it's in international units, and so is our stock dosage. So we're going to think about it, do that estimation piece again. Excuse me. So we want to give a little more than a mil, right? Because we know 300 is bigger than our 250, but it's going to be less than 2 mils. Okay, so let's calculate it out. So doctor's ordered 300,000, put it over top of our 250, okay, in 1 mil. So in this time, we're going to need 1.2 mils per dose. Okay, so again, multi-dose vial. We have a total of 4 mils as determined on the previous slide. Okay, so again, we can get 3 full doses. So the takeaway from this not only is that you can calculate it in different dosages, but also that by doing that, we still come to the same result of how many doses we can get, because we're not increasing the amount of total medication. We're just changing the concentration to either facilitate it being injected into a smaller space, so needing a smaller volume, more concentrated, or into a more compliant space, okay, where we can use a larger volume. Okay. So, drugs with different intramuscular and intravenous reconstitution instructions. Okay. So some drugs have different reconstitution instructions depending on the route of administration. Okay. So this label, for example, is talking about administration. And again, it's difficult to read because it's very small. But that we are to add 3 milliliters sterile water to yield a final concentration of 180 milligrams per ml, if we want to use the IM route. Okay? Or, alternatively, we could add 5 or 10 milliliters. Okay? So depending on which volume we're adding, this one or this one, we're going to then yield a final concentration of 180 milligrams per ml or 95 milligrams per ml. And that's how we can administer it IV. Okay? And as you can see, and as we discussed previously, muscle, excuse me, less compliant. Okay, not a lot of space for it to take fluid on. Okay, whereas an IV, you're putting that into the vascular space, so that's, you know, just enormous, and it's a lot less packed in densely with particles, right? We have fluid flowing through there. So you can add a larger amount of diluent to have this go in. Okay. So in this case, we would need to read our physician's order to establish route. Okay. And then once we've established route based on physician direction, we're going to calculate as per the above instructions as to which of the two of these we're going to need to calculate. Okay? Now, reconstituting non-injectable solutions. So sometimes, less frequently, I would say, than regular reconstitution in my practice anyways, sometimes as nurses, we need to reconstitute nutritional formula, irrigating solution, things like this. Okay? So when we're doing that, just remembering back to our reconstitution education, okay? The less solvent or diluent added, the more concentrated our final solution is going to be. So let's talk orange juice again, okay? So I bought my can of frozen concentrate to have with my lovely Sunday pancake breakfast. It says to add 3 cans of water. So I can add my 3 cans of water, and it tastes just right, just like the pre-mixed stuff you buy in the jug, okay? But if I add too much water, it's going to taste a little watery, right? But if I have more guests to my brunch and I'm cheap, don't want to buy 2 cans of concentrate, I can have more juice to go around to all my guests. Now, if I add too little water, it's going to be really sweet and concentrated, and I'll also have less juice, right? So just like we discussed before, the more diluent you add, okay, the more diluted your solution will become, okay? The less diluent you add, the more concentrated your final solution will be. In that case, you'll have less volume total, and in the diluted example, you'll have more volume total. Okay, but the concentration doesn't change with the concentrate. We've still only used 1 can of concentrate. Okay, it's just how much water we've added to then dilute it down and keep it relatively concentrated. Okay, so let's talk solution concentrations. Okay, so typically we use ratios for these solution concentrations. Pardon me. So when the strength of a solution made from a liquid concentrate, it expressed as a fraction. So the following will apply. The numerator represents the solute. Okay, that solute being our preordained, never-changing amount of concentrated powder, or if we're doing our orange juice example, our jar, our little frozen concentrate tube. Okay, our denominator is going to be the total parts of total solution. Okay, so that is how much, okay, total volume we're going to have. Okay, and the difference between, excuse me, the denominator and the numerator is going to be the number of parts of solvent. Okay, now I will not ask you this on a test, but it is good to know. It gives us a representation in a different form of the same sort of information, so a different way of conceptualizing it, which is useful for practice. Excuse me. I'm not going to put it on a test to have you convert between the two, but it's a good thing to have in the back of your mind to understand. Okay. So let's talk a couple examples here. Okay. So we want a quarter strength reconstituted orange juice made from frozen concentrate. So a quarter strength. What does this mean? So what does our numerator represent? Our amount of solute. Okay. Solute, numerator. Perfect. Okay. So that's 1 can. So we've used 1 can of frozen orange juice. So what does this denominator represent? 4 cans total. Okay. So that's the full solution. How much is really there? So when we're making our juice, we've used 1 can of frozen concentrate, okay, to get a total of 4 cans of volume, which means if we want to calculate how many cans of water we added, or solvent, we just have to subtract that total volume, take that total volume, and subtract our known solute amount, which means 3 parts, or cans of water were used. Okay? Excuse me. So, now we're talking nutritional formula. Okay? So, I want 1/3 of a strength of nutritional formula. So what does that look like? Well, our numerator is 1. So we know that's our part of concentrate or solute. Okay, so that's 1 part. Our total solution volume is 3 parts. Okay, so we subtract our 3 parts from our 1 part of known, and we know that we added 2 parts solvent to come up with that final concentration of 1/3 strength. Okay, so this is what it looks like when we do this. Okay, as I say, it's a good thing to understand, just because it gives you a different way of conceptualizing information. And that helps us be better rounded individuals to help do appropriate health teaching with our families, our patients, everybody, okay? So we continue. Reconstitution. Solute, substance to be dissolved, okay? Our hot chocolate powder. Solvent or dilutant is the liquid substance we used to dissolve our solute, okay? Solution, the end result of mixing our powder and our liquid together. Okay, so that's our end result. Or it may not be powder and liquid, it may be our reconstitution of concentrated orange juice. Right? Let's talk single dose vials, okay, versus multi-dose. Single dose must be discarded after removing enough for 1 dose. Single dose, 1 dose, not a trick. Okay, multi-dose vials may be reused, but you need to appropriately clean the top of the vial every time you put your needle in there, because otherwise you can transmit whatever happens to be on the top of that vial. Who knows what it touched between when you put it in the fridge and when you went back to it. Okay, so always be cognizant of that. So let's talk central tendency. Okay, just quickly before the end of the lecture. You spent 50 minutes of your time talking about this stuff, so let's talk the mean. Okay, so what is the mean? The mean is the most frequently used measure of central tendency, to us, we have a good idea of what average means, and that's what the mean is, right? It's the average of a data set, okay? So every time I give you guys a test, you're like, oh, what was the average? You know, how well did I do compared to the average? You know, it's something that we use quite frequently. People always want to know what average is and where they fall in that spectrum, okay? So to find the mean, what we do is, if our data set is 1, 2, 3, 4, 5, okay, we add up 1, 2, 3, 4, 5, divide them by the total number of samples we had, so that's again 5, okay, so when we add them up we get 15. Well, then we divide by the total amount of numbers we added, which was 5, so the mean in this data set is going to be 3. So the average of this data set is 3, okay? So mean, average, we got this, no worries. When I ask you on the test, you will know what I'm talking about. Let's talk median. So the median is the number that occurs in the very middle of the data set. Okay? So in our data set of 1, 2, 3, 4, 5, we have to order them numerically from lowest to highest value. Okay? And then we find our middle value. So in a data set of 5 numbers, we know the middle value, okay, is going to be the third value in. So in this case, it's again 3, because it is the number in the very middle of the data set when ordered from lowest to highest value. Okay? Now you want to ask me, what if we have 6 numbers in our data set? Okay? And the third number in is 2 numbers, right? Technically, these are both in the middle because it's not an odd amount of values. In this case, you can add the 2 together, divide by 2, and we get a median of 3.5. Okay? So that's how I want you to do that. So get all these little red distracting lines away from you guys. Okay? Let's talk mode. So the mode is described by the most frequently occurring number, okay, in a data set. So first, organize your data set, okay, to obtain the mean. Okay, that's fine. So then we look for the mode. So once they've been ordered numerically, you can tell, in this case, we have 2 ones. Okay, the more of a specific number appearing more than twice? No. So we know our mean is 1 in this specific data set. But it's always easier if you organize your data set from lowest to highest number, because then you're going to put all your ones in a row. You're going to put all your whatevers in a row, if you see what I mean. And then it helps you pick out what the most commonly occurring number is. Okay, and then that's our mode. Now, in this case, okay, technically we have 2 modes, right? Because we have 2 1s and 2 2s. So we don't add and then divide them by 4 to get our mode. In this case, the mode is going to be 1 and 2. So there will be 2 modes. Okay, so as opposed to our median, right, where we add them together and divide, the mode, you include both numbers. Okay, so for next week, okay, test number 3 will start at 6 p.m. Okay, you have 1 hour to write the test. Please arrive on time. Calculator, pencil, pen. Okay, no class following the test. So we're going to read that course handbook, pages 40 to 42, on math relating to IB calculations and complete learning activities. Now, just prepare this before you come, not for the test, but for the following week. Okay. Also, and this is incorrect because I haven't updated this. I will update this exam information for you. Okay. So final exam, which we should start preparing for following that test next week, will be written during class. I have a review for you, and I strongly recommend you go through the chapter reviews and also redo the test reviews for tests 1, 2, and 3. because those are comprehensive. The only thing missing from those would be the IV calculations. Okay, so that's on the exam review. Okay, so that's all I have for you. I wish you a very good week, and I will see you next week for the test. Okay, thanks guys.